Page number 6. Find the equation of the line in slope-intercept form that contains the point, -5, 8, and has the same slope as that guy. So let's find out his slope. Let's see, I'm going to solve him for y. So I'll subtract 2x from both sides, moving it to the right side. Notice when I brought the 2x over by subtraction, I park it right behind the equal sign. And that just helps me to get it into that slope-intercept form. So I'm dividing everybody by 5 on both sides. And so we can see the slope of this line is -2/5, so we need to have that. We also see his y-intercept, which we don't necessarily need. So let's see here. I want the line then that goes through the point, -5, 8, and has the slope, -2/5. So I'm going to get out the old point-slope form equation. I'm going to start substituting in y minus my y value, my slope, and x minus my x value. So I get double negative there, x minus -5. So let's take care of that and make that just a plus right now. Find the equation line in slope-intercept form. So we got to move it to slope-intercept form. So we're just going to distribute the 2/5, giving us -2/5 x minus 2. And then we'll add the 8 to both sides, 2/5 x, and when you add 8 to a -2, you get a 6. So that's your final answer. Y equals -2/5 x plus 6. 20, graph this guy. Was the test to see if it's a function? What is it a 1-to-1 function? What's the test to see if it's a 1-to-1 function? Y-intercept vertex, show how you got the vertex, find the equation, x symmetry. Wow, just about everything you can ask about that equation. So let's go ahead and start with get the equation in vertex form. So we're going to complete the square on it. In fact, what I may do, since I have to do that anyway down here, show how the vertex was obtained. So I'm going to do my complete the square down there, because to me that's enough to show how you found its vertex. Now if you didn't want to do it, we showed it earlier, you could do -b/2a. So I'm just going to group the first two. There's no coefficient, so I'm going to leave a little space there. See here, my magic number that I'm going to add, 8 divided by 2 is 4, 4 squared is 16. Now remember, I'm working all on the right side, so if I add 16, I gotta subtract that 16. And this should, at that point, be your perfect square. And we also have our vertex. So our vertex is at, now remember, it comes from here, the -4 makes it 0, so -4. And then outside, we also have a -4, so it's going to be left 4, down 4. There's our vertex, and there's how we found it. So let's graph this guy real quick. See here, he is a parabola that opens upward, because it's positive out front, positive x squared. Vertex is at -4, -4, right there. So there's our axis of symmetry. The coefficient here is 1, so if you'd like, this parabola is just going to go, that's like 0, 0, then 1 gives you 1, then 2 gives you 4. Remember our parent function, 1 gives you 1, go over 2, it goes up 4. So it'll be right there, it looks like. Oops, I think I'm over 1. Thinks I found a y-intercept when I counted over 2 up 4. Symmetry gives me these other points. Okay. So there's a pretty good graph of it. I think I'll find my y-intercept. Okay, I might label this point. Let's see here. Let's go ahead and find the y-intercept. Y-intercept is easy. All I'm going to do is put a 0 in for x. That comes out to 12. So when x is 0, it's going through 12, and so that's on your y-axis. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here is a 12. Y-intercept. Okay. Let's see here now. What's the test to see if it's a function? That's called the vertical line test. Vertical line that hits it in one point means it's a function, but if you can get one to hit it twice, it's not one. So any place I draw a vertical line on that parabola, it only hits it in one spot. Is it a one-to-one function? And D, they kind of go together. What does it mean? For one-to-oneness, you use what's called the horizontal. Horizontal, if I could spell. Horizontal line test just says if you draw a line horizontally that hits it in 2 points, then it is not one-to-one. And one-to-one simply means, A, it passes the horizontal line test, but it means not only is it a function where every x goes to exactly one y value, but every y goes to exactly one x. So this would be allowed in a function that is one-to-one, or just a function rather, not one-to-one. In a regular function, you can have different numbers go to the same value. 1 can go to 2 and 2 can go to 2 in functions. What you can't have in functions, remember, is 2 going to 3 and then 2 going to something else. They can't do that. One-to-one functions restrict even a little bit further. This, when they're one-to-one, this is not allowed. Okay? One-to-one, not only does each x go to one y, but each y can only pair with one x. And so here you got 2 pairing to 2 different things. 2 goes to 1, 2 pairs with 3. That's not allowed in one-to-one functions. One-to-one functions, each x goes to one y, each y maps to just one x. So you can never have repeats of anything. Okay? Horizontal line test tells you that. Oh, and by the way, if it passes the horizontal line test, then it has an inverse function. We'll talk about that more later, but inverses are functions that undo others. This one does not have an inverse. Y-intercept, I found that earlier. We'll give the coordinates for it. It's at 0, 12, where it crossed the y-axis right up here. Vertex, excuse me. How did I do it? Just showed you how I did it. Equation for the axis of symmetry, we already gave that. X is -4, the vertical line. Domain, all real numbers. You can plug in any x you want, but not every y comes out. The lowest y that comes out is a -4, and then all the other ones are bigger than that. So for our range here, we'll put the y values are always greater than or equal to -4. X-intercepts, and I think I found them. I think there's an x-intercept at -2 and -1, 2, 3, 4, 5, 6, -6, I think. But to find it, I'm going to take that polynomial, x squared plus 8x plus 12, and I'm going to factor it as x plus 2 times x plus 6, and I can see my x-intercepts are at -2 and -6. So yeah, that worked on my graph. I could see them. And so I would mark those if you haven't. Since you know the x-intercepts, mark them and draw your graph through them. Show algebraically how the x-intercepts were obtained. So this work I should put down here, and then maybe show this part. To demonstrate that I knew how to find them. All right, that takes care of page 6.